All right. Happiness is understanding physics. Welcome to By Excellence Tutorials, where we make you have a comprehensive understanding of the concepts of physics. Well, the question here that we're going to solve says a 23-gram bullet traveling at 230 meters per second penetrates a 2-kilogram block of wood and emerges cleanly at 170 meters per second if the block is stationary on the surface with a coefficient of kinetic friction of 0.05 when hit. How far does it move after the bullet emerges? All right, so we're going to approach this question in this way, that conservation of linear momentum. Yeah, we're going to use the conservation of linear momentum and of course dynamics for the block of dynamics for the block. Then we'll be able to get what we are looking for. We are looking for the distance or the displacement of the block. So let's say we have a bullet that is moving, and we have, what's this? We have a block, all right? It's stationary. So let's say this is U1 and U2. Here is 0 because it is at rest. This one is moving at 230. So it penetrates, and then after, what we see is that obviously we'll have the block from the initial position 0. We take it to be 0. It would have covered a certain distance. And the bullet has penetrated with the final speed of 170 meters per second. But we don't know the final speed of this block. And we are looking for this distance here that it covered. So how do we get that distance? So we use first conservation of linear momentum. So what we're going to have is the initial momentum of the block plus the of the bullet plus the initial momentum of the block should be equal to the final momentum of the bullet and the final momentum of the block. All right, so here it will help us to find the final speed which it moved with the block for us to know how far it moved. All right, so this one is 0 because it was at rest. So we have a bullet that is 23 grams, so we convert it to kilograms, which is going to be 0.023 kilograms, and that we multiply by the speed, which is 230 meters per second, equal to 0.023 kilograms times the final speed of the bullet, which is 170 meters per second, plus the mass of the block, which is that, times the final velocity of the block. So what do we get? So we have 5.29 being equal to, sorry, I have a bit of flu. Yeah. So we multiply this. Here we get 3.91 plus 2v2, like that. So we take this guy, the other side, it will be 5.29 minus 3.91 equals 2v2. 5.29 minus that, we get 1.38 equal to v2. We divided by that, So V2 is going to be, or the speed of the block after that images 0.69 meter per second. Okay, so this was the speed. Now let's look at the block in this way. Now we've known the speed. Now let's look at the forces now of this block. So this block is moving in that direction, or is to move in that direction. That is after the penetration. Immediately after the penetration, we see the block moving in that direction, in the X direction like that. Now, if it's moving in that direction, we know that we're going to have the normal force, and then we have the weight of this block. So, and then in this direction, we're going to have the friction force, all right? So this is moving in that direction with that acceleration. So now we're going to have the forces in Y, they equal to 0. So we have normal force minus mg equal to 0, normal force being equal to mg, or 2 times 9, 8 Newton, of course. So this is going to give us what? 19.6 Newton. All right, so we have the normal force as 19.6 Newton. And then what else do we have? We have also motion. Okay, so let me write motion in X from this side. We have MF. Now, what are the forces in X? We only have the friction force being equal to MF. Now, one thing again we know is that friction force is given as nu times normal force. So we can substitute there. We had the nu. We have the nu. I think we had the nu. We're given the nu in the question. Let's check it. Okay, so we have nu, it's 0.05. All right. .05, that's our nu, or the coefficient. So what we're going to have here now is that this friction force is equal to 0.05 times 19.6 Newton. So the friction force is 0.98 Newton. So what we see here is that this friction force is the one that is causing motion in X. So now, remember that we have under kinematics, we have this formula, v squared minus this 2ax. Remember this formula? So that acceleration is given by that. So we substitute this formula in this equation of force. Excuse me. Sorry, this has been a terrible video because but I have a flu. I'm really sorry. All right, so we substitute the acceleration equation in this one. So we are going to have the friction force, which is 0.98 Newton, equal to mass times v squared minus u squared over 2x. Okay, so now can say 0.98 Newton equal to the mass is 2 kg times the final velocity which is 0.69 squared minus this one. It was at rest. So 2x. So that and that can even go. So that what we have is going to be 0.98 Newton, of course, 0.4761 over x. So x is going to be that one. We get 0.486 meters. So this is the distance it moved after the bullet emerged, and this was the displacement or the distance. So this is how you find this question. So I know that you found this video to be helpful despite the flu, sneezing part and all that. Yeah, but give it a like, a comment, and share with your colleagues as well. Thank you so very much for your time.